Hi, this is Fintan Ryan from RedMonk here, and I'm joined by Jeremy Patton from Ericsson today. We're going to have a little bit of a talk about how Ericsson are using blockchain on GE's Predix platform. So firstly, Jeremy, would you like to introduce yourself?
Yeah, so as you said, my name is Jeremy Patton. I was the developer for the Ericsson blockchain service that's now available in GE Predix platform.
Cool.
So,
So before we kind of jump into the details, there's a couple of kind of background questions we'd like to touch on. So most of the audience that are going to be listening today are pretty familiar with blockchain and the general distributed ledger technologies, but kind of wondering, could you talk to us a little bit more about this blockchain data integrity idea that you have within the Ericsson solution and why it's useful?
sure. So our blockchain is not quite like other blockchains. We're really providing a ledger that stores a cryptographic hash value and not transaction data. And by storing these hash values, we can prove the integrity of data by comparing the hash value stored in the blockchain with the current hash value of your data. So this becomes very useful in proving the integrity of any data in near real time. So for example, it could be used in notifying support personnel in the case of compromised data or even a breach of a network, depending on what types of data has been signed and is being monitored. So you can see here, that the useful benefits is the undeniable proof of integrity in near real time. And by operating as a service here, we drive down operational costs. And then we use the cryptographic fingerprint with a hash. So it's extremely scalable, and it also ensures that no customer data is leaving Predix in this case. And it's only a hash value that's stored on the blockchain.
Okay, cool. Yeah, that makes sense. It's a really interesting usage for blockchain because there's so many kind of presumptions of everything has to go into the blockchain rather than it being used as the validation mechanism. In terms of keyless signatures, could you talk to us a little bit more about what a keyless signature is and the underlying keyless signature infrastructure?
Sure. So the keyless signature is an infrastructure where we don't use secret keys at all. Instead, we use a widely witnessed event to prove the integrity of data. The widely witnessed event itself is the publication code of the signature. The code of the signature is published to Twitter and other data journals. And the keyless signature infrastructure is used to provide is provided by Ericsson as a service, and it brings down the cost to users of the blockchain so that they don't have to pay to build out their own blockchain infrastructure. So here on the screen you can see a diagram. We have different aggregation trees all over the world that combine up into the one root calendar to generate the keyless signature.
Cool. It's a really interesting approach. I know when I was reading up it, I know that one of the keys gets published on the FT website, I think, as well, which is I guess
Financial Times.
Yeah, a bit of a nod to I guess how some of the fintech folks are thinking about stuff as well and are always looking at this. I guess from a RedMonk perspective, our bread and butter is what developers do and where they spend their time. So, in terms of the developer abstractions and kind of entry points into using everything, could you talk a little bit to us about that? And I guess we'll probably end up touching on some of that in the demo as well.
Yeah, sure. So really, this is a really simple service to use. It's a REST APIs, and there's only two entry points. One to sign your data, and then one to verify that the signature's intact and valid, and so that you can verify your data. So with that, I guess I'd like to start and take you over to kind of the GE's website, the Predix catalog, and show you, you know, right here is our service in their catalog. And if you go into their documentation, you can see here the APIs. This one lists 3 APIs. We've recently provided an update so that the extension now is part of the details API. The details is the verification, and then this V1 proxy signature is used to create the signature. So these are our 2 main entry points into the service.
Cool. Very straightforward and easy to use.
Yes. And then a little bit further, we got, if you continue on with their documentation, they have information on how to set up set up the service and set up the UAA and all of that. These are the things that you need to be able to use the service within Predix. And so all of this is described here. You can follow it step by step to get everything set up to use in Predix.
Cool. Would you like to kind of show us this in action?
Yeah, sure. So I can show you, start with, I guess, kind of a couple of little demos first, and then we can go back and look at some of the code to see how things are done, if that makes sense for you.
Yeah, that would be very cool. Thank you.
So the first little demo I have here is just a test application that we created a long time ago to sign a file. So here we can just upload a basic file, whatever we want, and hit sign. And it uploads the file and signs it. So whenever you create a signature, you give it a hash, and this is what you get back. This is the signature, the decoded signature. The user clients need to store a signature, which is the encoded part, this part right here, and associate it with their data somehow for verification later on. So this is the encoded signature, and then all of this is the decoded signature. You see right here, it says our data hash, we used SHA-256, so that was the cryptographic hash, and this is the value of it. This is what we sent in to be signed. So this is what's on the blockchain. And then the identity tells us who signed it. So this, all of these Ericsson parts is it's going through the blockchain infrastructure. And Predix was kind of our gateway into the infrastructure. And then this is, I guess, kind of, it's the user, but in Predix, it's more like the service instance that requested the signing. So, you know, if this being a web application, there could be many users that wanted to sign a file, different files. And so, you know, this would be like your UA client ID or whatever. There's one service instance here, and that's what that would be. So this shows what a signature is and how it's created. And this was created through that one API. Let me go back and see if I can go back to that real quick. Through this one API right here, the V1 proxy signature. And then so we've got another little more full fleshed out demo here that shows kind of a industrial workflow type thing. So you can see here, this is kind of wide. We got a set of work orders or assets, and we keep a ledger log of when they've been updated or maintained, or performance has been, or maintenance has been performed on them. And so we keep a log of that, and each time that's done, it's signed, and then the next one is maintenance is performed and it's added on and signed again. So we use this to see that all of these maintain their verification. Nobody's gone in and modified results since it's happened. And then the whole log itself, the whole ledger has been verified. And so you can see here, this is again like our hash value that's been stored on the blockchain. And this shows, you know, that it's verified and passed. So this is more of a how it could be used in type of a full-fledged type application.
Cool. Having in my distant past, having spent time having to work out firmware problems while doing performance benchmarking, I can see some definite applications with this.
Yes, yeah.
Oh,
And so now I guess we can just um, sort of dive into the code and what you need to do, make the API calls and how to make them. So we've got some sample code here in JavaScript. So you can see here, let me see if I can increase the font size a little bit here. Okay. So in this one, we've pulled in BP promise and request for the simple HTTP client type. And then this information here is information that you need, your Predix zone ID. That was in the documentation. And then your UAA information, because it requires a UAA OAuth token to OAuth 2 token to authenticate against. So I can switch over real quick and show kind of like an environment of an application that's been bound to a service. So let me log in real quick here. So you can see this is an application. I've bound it in Predix to the blockchain data integrity service. And we see the information here. So this is the URI to connect to that service. And then when we want to make a specific API call, we add the API endpoints at the end of it. Mandatory HTTP header is the Predix zone ID. And then the value that you will be using. So this is your service instance ID. And then this OAuth scope is used for setting up your OAuth 2 token in the UAA client. So all your information is here once your application is bound to the service. And again, all of the Predix documentation steps you through step by step on how to sign up for the service, how to sign up for your UAA, configure everything, configure your OAuth tokens and everything.
cool.
And so with this, then we can go back and let's see, where was I here? So this information here pulls it out, and you can get your token, your bearer token, and you have your header value. So then the next method portion I'd sort of like to show you here is actually creating the signature. So here you pass in a hash value. So let's back up real quick and see how to do that in JavaScript. So let's see over here. Bear with me, I had it. Let's see. There we go, get hash. So you can see right here, they just use the crypto create hash algo and they pass in their data that they're wanting to digest and put it in base 64 and generate the hash. And so this is what the hash itself is, what's passed in to the create signature method. And it builds up this little JSON data structure with the algorithm that you're using, SHA-256, and the value that was passed in. And this is the JSON data that's passed to the V1 API app v1 signature API. And you see right here, we're calling it and we're passing in, we're setting our Predix zone ID header, we're setting our authorization header with our bearer token, our content type application JSON, and then we should expect a response 200. If there's an error, well, then all of this is error handling basically. So you can see here, it's real simple and straightforward to create a signature. Verifying a signature is just as easy. Let's see, right here's the verify signature. So they've got the base URL and then it's the v1 proxy signature details. So that's what you call to verify. And again, like I showed you before, the encoded part of the signature that you have to store and associate with your data, that's all that's being passed to verify signature. So what this does, it takes that signature to the service. The service rebuilds the blockchain based upon that signature to verify it's a good signature item, and then it returns back to the user the decoded signature so that they can pull the hash value out of the signature blockchain element. You take that hash value that's stored on the blockchain in the signature and compare it to the current value of your the current hash value of your data. And you do that, and then you've now verified that your signature hasn't been corrupted, that's been stored on, and you verify that your current version of data has not been corrupted based upon what was signed. And then that's it in a nutshell. That makes it straightforward, simple, quick, easy to use.
Yeah, very like anyone who's familiar with any programming language and interacting with REST APIs will be able to use it, but they get a tremendous amount of power out of kind of the underlying infrastructure and everything that's happening.
Yeah.
Cool. Very cool. Thank you very much. With that, I'd like to say thank you very much to Jeremy for joining us today. I hope people have found this interesting. The ability to use blockchain without having to worry about all the underlying complexities is very, very powerful. And I think the whole keyless signature aspect is incredibly interesting as well. So thank you very much for taking the time.